are going to be doing pretty much the same kind of question all day today. We're going to do skill building. Essentially what we're going to be looking at is how to find the exact value for the slope of a tangent line to any curve, y equals f of x, at x equals a. There's actually two different ways of doing this. The one I'm going to focus on, and it's one I use mostly, is this one. So if you can calculate the limit as h tends to 0 of this expression, what you're essentially doing is you're finding the slope of that secant line from P to Q. But because you're making h tend to 0, those 2 points, essentially Q, comes closer and closer to P. And if you can imagine that process continuing forever, the logic says that eventually the two lines will, for all intents and purposes, they'll meet up so that the slope of this fella, PQ, will become the slope of the tangent line. And we're going to be doing it for polynomials. We're going to be doing it for radicals. And we're going to be doing it for rational functions as well. So I'm basically just going to pick a question that has a polynomial in it, do it again, get practice at that process, doing it for a square root function essentially, and then doing it for a fraction, and work through this limit process, and hopefully we'll get good at it, and so that no matter what the function is, we should be able to do it. So the only difference is going to happen for some of the questions today is that yesterday when we did it, a was a number. It was like the slope of the tangent line at 3 and a turned into a 3, or it was the slope of the tangent line at 5 and a turned into a 5. So that would become 5 plus h take away 5. And we will do some questions still like that. But we're also going to do questions that just use a, which is actually a much more useful version of how to do that. So this is a version of question 1. The function we're going to do it to is a quadratic. And we're going to do it at, did they use a equals in this? I'm just getting used to the notation. Okay. We're going to do it at x equals 2. There we go. So I want to find the slope of the tangent line of this quadratic when the x coordinate is 2. So we can go straight into the slope of the tangent line. And here's some notation for you. F dashed of 2. And that just means the slope of the tangent line to the function f when x is 2, right? So that's just a little cleaner math. It's also called the derivative at 2. You want to use that term. Let's see what it's equal to. It's going to be the limit as h tends to 0 of, instead of a plus h, it's going to be 2 plus h. Take away f of 2 all over h. Right, 2 plus h, that's 4 lots of 2 plus h squared. Take away 5 lots of 2 plus h plus 1. Subtract. If you plug in 2 here, you get 2 2s 4, 4 4s is 16, 17, 7, well, let's check that, 2, 4, 16, 17, take away 10, so you get take away 7. Let me treble check, I just don't want to do this wrong, 16, 17, 10. Okay. Don't know why it looks wrong. Over H. I'm going to FOIL all this out and multiply this guy by 4. So it's going to be 4 times 4. So maybe I shouldn't do that. Okay, I'll do one extra line. And this time I'll remember, because I forgot it here and here, to do the limit as h tends to 0. So it's going to be 16, 16h, 4h squared, take away that guy, take away that guy, plus that guy, minus 7 over h. Now here's the first thing that is going to happen, and it better happen or else I've screwed up. All the numbers should cancel out. 16, take away 10, that's 6. 6 add 1 is 7, take away 7, bingo. If you do not get all the numbers to cancel out, you've screwed up, because they always do. Now that's going to leave me with this guy and this guy, which is what, 11h plus 4h squared over h. So if you do this correctly, you're going to get to a point where there's only terms that have h's in them. There won't be a plus 3 left over anywhere, right? That's a good sign. So the next step is very, very common as well. What do you think is going to happen on the top line? What do you think I'm going to do with that expression?
Factor out the
Factor out the h.
Right. And that's a very common thing. That happens a lot. Now, what's going to happen now, of course, is we'll cancel them out. So essentially factor and cancel. And at this point, the limit is basically just brute force, plug in 0. And there's your answer. The slope of this curve, this quadratic, at the x coordinate of 2, so I'm making no attempt to be accurate, but can you imagine that's it? At x equals 2, that tangent line, that guy there, has a slope of 11. And that's the exact answer. It's not an estimate, it's a true value. It's what it is equal to.
Where did you get the 7 when you started doing that?
The 7?
Yeah.
Yeah, I found the value of the function at 2. I found essentially what f of 2 is. So I went 4 lots of 2 squared, take away 5 lots of 2 plus 1. And I had to do it a couple of times because I don't trust my mental arithmetic.
Okay, sounds good.
Okay. Now, imagine I then went and said to you, I want to know the answer at x equals 4. I want to know the slope of the tangent line at x equals 10. Oh, and at x equals 3, 5, and 6 while we're at it. Can you realize that if I did it this way, wouldn't I have to do a whole load of the same kind of working with slightly different numbers every single time? Wouldn't it be nicer if there was an algebraic way of maybe only doing this once and then using the answer to find out the slope of the tangent line at 2 and at 4 and at 5, 6, and 7? And the answer is yes, there is a way to do it. So let me show you. This is also like question 1. And I'm going to use the exact same function, but I'm going to do it at x equals a. So I'm not going to give you a specific x coordinate. I'm just going to use the letter a to represent whatever the x coordinate happens to be at any given moment. Now, that means that we're going to be finding the slope of the tangent line at a. That's fine. And the formula really doesn't change at all. So now we are going to do this entire process totally in a general way, right? There's no particular x coordinate. It's called a here. The function happens to be this quadratic, but that's not in itself a big deal. So let's see what we get. Well, you get 4 lots of a plus h squared. Take away 5 lots of a plus h. That's not a big deal. Plus 1. Okay, that's the first guy. Take away f of a is 4a squared. Take away 5a plus 1. And the whole thing is over h. Why do you think f of a, this expression is f of a, why I put brackets around it like that? What am I trying to make sure I do?
Distribute the negative sign.
Yeah, because one of the mistakes that people make is, if they're not careful about that, is that they only subtract the first term and the other 2 terms don't get subtracted. So it's just for emphasis. So here we go. Too much going on here for me to do it, in one go. So if you FOIL this out, you're going to get a squared plus 2ah plus h squared. You distribute this one, you get minus 5a minus 5h, and you still get plus 1. And then you take away each of these. So I'm going to distribute it. It's going to take away that guy, going to add 5a, going to take away 1. It's over h. Distribute the 4 now. So it's going to be 4a squared, 8ah, 4h squared, take away 5a, take away 5h, plus a 1, take away that guy, plus a 5a, take away 1. Now that is a pretty ugly expression. Let's see if anything nice happens. Okay, let's see what we can do when we collect like terms. Do you notice that that number plus 1 gets killed off with that negative 1? Did you notice that this negative 5a gets killed off with that plus 5a? Did you notice that that 4a squared gets killed off by that negative 4a squared? And the only things that are left alive are 8ah, 4h squared, take away 5h. So if you do this process correctly, the only terms that should be left alive, all of them should have an h in them, at least one h, right? It may have an h squared. If you have a plus 4a left over, or a minus a squared left over, or whatever, you've screwed up. Go back and figure out who didn't cancel out who, because they always cancel out in polynomials. Now this is now going to be the limit as h tends to 0. I hope we kind of know the next step, because it always kind of happens, doesn't it? So I'm going to pull out an h as a common factor. So far, so good. And this guy cancels that guy. And so we're looking at 8a plus 4h, take away 5. And now we can just basically replace h with 0. And what do you get? 8a plus nothing, take away 5. And that gives me the answer 8a, take away 5. So the slope of the tangent line at any given value x equals a is 80 minus 5. Now let's check that that worked. Remember the one that we did here when x was 2, we got a slope of 11, right? Well, according to this then, if I did 2, shouldn't the answer be 8 times 2 take away 5? Isn't 8 times 2 take away 5, 11? Right, so it does match it. What's good about this is, if I wanted to find the slope at x equals 1, don't I just make a1 and get the answer 3? And if I want to know the slope at 20, you know, when x is 20, don't I just make a20 and the answer is 155? So by doing it this way, don't we only need to do the algebra once, and then we can use this answer for any x coordinate we like? All we do is replace the x coordinate, or think of the x coordinate as being the a value. Any questions about that? Would you agree that's mathematically, that's a more efficient way of tackling the problem of not focusing on one value, but focusing on a general value called a, and then you can use it in lots of different situations without having to do all this thing every single time. So that is us taking care of polynomials. Check. Next guy I'm going to do is going to be, if I can find it, if not, I'll make one up. It's going to be a radical. Okay. So the function that we're going to find the slope of the tangent line for is going to be 3x add 4. And we're going to do it at x equals 2. And I have just found out something that's kind of helpful. They call it a equals 2. Okay, a equals 2 is the same thing as saying x equals 2. I was wondering if they would do that. Excuse me, I am going to do 2 versions of this question. The only one you actually need to do for the homework was the one where you used the number 2, right? But I'm going to do the number 2 and then the a, so that we can get practice at doing it with a number and practicing doing it with an a, because in the homework they do that. Sometimes it's a, you know, it's 3 and sometimes it's a. So the derivative at 2 then is going to be the limit as h tends to 0 of 2 plus h take away 2 all over h. In this case, it's going to be the limit as h tends to 0 of, let's see if I can save one line of working. If you plug 2 plus h in here, don't you get 3 lots of 2 plus h add 4, right? So what's that? 3 lots of 2 plus h, that's 6 plus 3h plus another 4. Okay. And this side, plug in 2 and you get 10. So what I have is 3h plus 10 take away 10 over h. You do not need to write this line down. I'm just repeating myself because I didn't plan ahead. There, now I've got enough room. How am I going to solve this one?
Conjugate method.
Great. Square roots are conjugate method. So this fella is going to be square root of 3h plus 10, add square root of 10. Bottom's going to be the same thing. Okay. Now let's see where this goes. Don't do anything to the bottom. Except multiply them together. Right, if you take this guy and you multiply him by this guy, can't we just do the shortcut, which is first guy squared, take away second guy squared, right? First guy squared, subtract second guy squared. If you square this guy, you get 3h plus 10. Take away, if you square this guy, you get 10. And lo and behold, something really pretty happened. The 10s cancel out. Which means I can now do the cancel. Which tells me that I've got 3 left on the top, a couple of square roots on the bottom. I can now plug 0 in, and that gets me 3. 3 lots of nothing plus 10 are still 10, so I get root 10 plus root 10. This becomes 3 over 2 square root of 10. Could we make it prettier? What would I need to do to make this look a little bit nicer?
Multiply the top and bottom by 2 times the square root of 10.
Okay, so what we're going to get is 3 square root of 10 over 20. Yeah, I like that answer. For a numerical answer, that's quite nice. And do you notice it's a bit ugly, but it's a perfect answer to the slope of the tangent line. You couldn't do that numerically. You wouldn't be able to guess what the decimal that you think it rounds off to was actually this fella. There's so many other guys it might be. You wouldn't guess it. I think you'll notice that these are not short questions, right? You don't get many of these to the dozen, right? Which is a kind of stupid saying, isn't it? Because you always get 12 to a dozen, but whatever. Same function. What we're going to do to x equals a. So we're going to generalize it now. So it's going to be the limit as h tends to 0. F of a plus h. Take away f of a over h. If you put a plus h in here, you get 3 lots of a plus h, add 4. And if you put a in here instead of x, you get 3a, add 4, over h. So that's 3a plus 3h plus 4. Take away 3a plus 4 all over h. Now, although it's a little bit distracting because there's an awful lot going on inside this square root in particular, it's really just a conjugate rule, which means it's the same 2 square roots, but with a plus. It's still the conjugate rule. So it's going to be 3a plus 3h add 4 and 3a add 4, top and bottom. And there's the 2 guys at the bottom multiplied. This guy, take away that guy, multiplied by this guy, add that guy. Let's do the shortcut. First guy squared, 3a plus 3h plus 4. Take away second guy. Do you notice I put the brackets around to make sure you distribute the subtraction? And something very nice is about to happen. Don't the 3a's kill and the 4's kill? If you do these correctly, there shouldn't be any numbers left on the top, right? It should just have h's. In this case, cancel them. I was just thinking, I wish I had one of those wooden stencils where I could just go gadunk, 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 so I didn't have to keep writing this bloody line. Yeah, can you imagine making a little wooden thing that had this on it, and then you could just put it in ink and hit it, and it'd save you having to repeat yourself. People would buy something like that.
Yeah, a little stamp that you can just like, it's like one of the date stamps that you just roll it and then just.
Yeah. Somebody should invent one for math, right? Where you could just twiddle about and get what you wanted, and then you could just say, you know, because some of these questions, don't you end up writing the same damn thing about 5 times because the bottom never changes? And it wouldn't be bad if it was just 2x, but it's a big, horrible thing this big. I know, what could you could probably do dash dashed or something saying it's the same as the above. Right, let's put in 0 and see what we get, because we should be able to get the limit now. If you put 0 in here, you get the square root of 3a plus 0 add 4 plus the square root of 3a add 4. Now you try and make these as pretty as possible. So this guy and this guy is the same guy. And I'll leave it like that. Now, could I rationalize the denominator? Sure, but let's not bother. Because see, if you did, the answer would look like this. Would you agree that that is actually uglier looking mathematically than this? So sometimes rationalizing the denominator is not a benefit. It's typically done always with numbers because we don't like square roots when we've really got numbers. But when we've got expressions, we're much more lax about what something is in its prettiest form. To me, isn't that quite a pretty form? It's quite an elegant, everything you need to know is there. Now, if I wanted to find the slope of that original question at x equals 2, don't I just replace a with 2? If I want to know it at 0, I put 0 in, and if I want to know it at 849 million, I only need to put in 849 million there. And that has reduced our workload by a lot. Any questions? Apart from the fact they take forever, they do have a flow to them, don't they? Right? Agreed? Got a nice flow to them. You could stick any function you like, essentially, couldn't you? And as long as you can play about with it algebraically, you should be able to get something at the end, right? So my last guy is going to be fractions, right? I find one, if not, I'll make one up. Let's see, are there any nice fractions floating around here? Fractions are the worst to do, so they don't have too many of them. That's not pretty. I'm not doing that one. Not until we have to. Oh, that's interesting. I don't want that. Nope. No. Okay, I'll do mine. Fractions are notoriously ugly to work with algebraically. So I've picked the simplest one I can think of, just so we can get the practice at it, and then Tomorrow I'll go back to that one, says I'm not doing that, right, and show you it, because I can't avoid it forever. But I don't want to do it right now, because let's just take it small steps before we jump into the deep end. So here is a function, and I would like to know what it's like at 1, right? So I'd like to know the slope of that tangent line at x equals 1. So that guy. So it's going to be the limit as h tends to 0 of 1 plus h, and take away 1 all over h. And I'll give you a little warning here. Even this isn't going to be nice. So it's going to be 3 over 1 plus h, take away 3 over 1. You're going to have to deal with an expression when you do rational functions. They're all going to look something like this. They're going to be 2 ugly fractions on the top all over h, right? That's kind of what's going to happen. And so we need to figure out how to, deal with this, how to simplify it, and so that we can, continue the process. There are 2 distinct ways in which you can do it, and both work. I'm going to show you one of those 2 ways, and I'll tell you the other. I am going to use the technique that you can sometimes use, or actually in fractions you can use it, of multiplying by a special version of 1. And the special version of 1 I've chosen is 1 plus h over 1 plus h. It's not the conjugate method, right? The conjugate method, you multiply by a special version of 1, but it's got square roots in it. Do you see this one? Do you know why I picked 1 plus h and not h or 42 over 42 or whatever? Why is it a 1 plus h and not anything else?
So it'll cancel with the first fraction.
Yeah, that's the guy I don't want. If he goes away, this expression should turn into something, doable, right? Something we can work with. Now, this hasn't happened, but do you know how this is 1 plus h and this is 1? I'm cool. Imagine this was 1 plus h and this was h, right? Just for argument's sake, right? This is 1 plus h and this is h. You would still do this, but you would do a 1 plus h over a 1 plus h. In other words, whatever the 2 denominators are, both of them together make up the magic version of 1 here, right? So back to this guy. It's going to be the limit as h tends to 0.
Wait, if it was 3 over h, what would it be?
Yeah, if it was this guy, right, say take away that guy, the version I would use would be h 1 plus h. See, the h takes care of this guy and the 1 plus h takes care of that guy, but I need both of them to take care of both of them, right? So you can't do it with just one on its own, you need both together, right? In this case, we got away with it because I picked a nice easy one, but you can imagine in the future, there are going to be 2 ugly fractions to deal with typically rather than just one, right? If you multiply this fella by 1 plus h, do you see that it's no longer a fraction? Which is kind of why I did it, right? And if you take -3, because that's all that is, you get -3 1 plus h's. And on the bottom, you get that. And now, I'll distribute. Right, we cool on that? I could have probably went from there to there in one go if you wanted to, but you're happy about why that becomes this? Right, -3 1 plus h's, distribute the -3. Okay, what happens here, which is really nice, is that the numbers cancel. And now we have the limit as h tends to 0 of negative 3h over h 1 plus h. Have you seen that this ugly guy, right? That was the guy we started with. See this fella here? We really can't do much with that, right? Have you seen that it's now turned into this fella? And this fella has got that. Oh, cancel. And so we now have the limit as h tends to 0. That.
How are we going to get rid of the h on the bottom?
Oh, dead easy. This h here. Is that the one you're talking about, Robin?
Yeah.
Right. In a few seconds from now, I'm going to make h 0 because the limit as h tends to 0. What you get is negative 3 of 1 plus nothing. Negative 3 over 1. It's gone. It's not in a bad place because it's got a 1 plus next to it. On its own, it would be dangerous, right? But 1 plus it is pretty much easy to deal with.
Yeah, I was confused about that. I thought it was going to make it indeterminate form again.
Are you comfortable that it didn't? Does it make sense why it didn't?
Yeah.
So, pretty cool process, isn't it? That we can do fractions, we can do quadratics. I could do cubics, but they just take, they're that big, right? You could do it, but I'm not going to. And you can do fractions. And to finish, that could be perfect timing today. Same function, but we're going to do it with the x equals a method, right? So we're going to do the general version. And so it's going to be the derivative of a is the limit as h tends to 0 of this guy. Take away this guy, and h. So it's going to be 3 over a plus h, take away 3 over a, all over h. Are you happy with that line? A plus h gives you this guy, a gives you this guy. Put a little bracket around it. Okay. We're going to do that multiply by a special version of one trick. What will be the special version of one that we should use here?
Wouldn't it be a plus h?
Anything else?
Multiplied by a.
Yeah, you need both. A takes care of this guy, the a plus h takes care of that guy, so you need both. Make sense?
Common denominator, yeah.
Yeah, it's essentially a common denominator. Which reminds me, I said there's two methods and I never told you the second one. The second one is you just add, so in this case, subtract these two fractions by converting them to share a common denominator and then subtract. I don't like that method, but you can do it and it works fine. So what do we get? We get the limit as h tends to 0. On the bottom, we've got, these are all multiplied, so I guess I could put them in any order I like, right? When you multiply things, aren't you allowed to shuffle them in? It doesn't matter. It just looks better to have an A, then an H, then that guy. I'm just putting the three things together. Right. This fraction times this guy. Write that down separate. I'm going to multiply this guy by that fella. Did you notice that those cancel? And the answer is 3a. Are you happy about the 3a? Okay, what is going to happen when you do 3a times these two guys? Don't worry about the bottom. The bottom's already been dealt with, so there's not going to be another a plus h floating around. If you take this guy times that, what do you get left over? Or what's the answer? Three over a times A plus H times A.
3A plus H.
That's the what I wanted to hear. And you notice the subtraction still there, right? What I'm now going to do is distribute the 3, or the negative 3. And almost like magic, don't the 3 A's cancel each other out? And when I look at this question, especially the numerator, because you tend to look at the numerator in these questions, aren't I happy that there isn't a plus A left over or a plus 2A left over? Because if there was, I know I've done it wrong. And since these questions are really long, you want to stop at any point when you know it can't be that, because you must have made the mistake somewhere up here. Don't try and keep going with it and then thinking maybe it'll sort itself out at the end. It won't. If you have a negative 3H plus anything that's not an H in it, it's wrong. That's just the way the math is going to work. Now in this case, aren't the H is going to cancel. So that means I have the limit as H tends to 0 of negative 3 over an A plus H. And if you're worried about the H, it's not a problem, because can't I just replace it by 0 and let's see what we get? Negative 3 A plus nothing. Well, isn't that just A? So would you get negative 3 over A squared? And now I can find the slope to this function at any number A I like. If I want to know the answer at 1, isn't it negative 3 over 1 squared, which is negative 3? Already done that one. But if I wanted to know it at 10, wouldn't the answer just be negative 3 over 100? If I wanted to know it at 42 million, thank God I don't, but if I did, wouldn't it be negative 3 over 42 million squared? And so what you're getting out of this guy is a single formula that will allow us to get any tangent line slope we want, right? Any A you like. Now, I'm going to finish off any second now. I want to show you something that is really cool. Right, there is a quadratic. Can you just trust me that the answer ends up being that? Okay. Now, slopes of tangent lines, right? So you do a tangent line, you get a slope. If you look at this quadratic, doesn't this quadratic probably look something like that, right? One of the things that we like to find on curves are bottoms of valleys. What is going to be the slope of a tangent line at the bottom of a valley like that?
0.
And so if I find out what value of A makes this 0, won't I have found the location of the bottom of the valley? You see, we now have a way to find out exactly where tops of hills and bottoms of valleys. You couldn't do that in 141. You know, you could do a graph of it and guesstimate it, but now we'll be able to find an exact way to do it. And that's kind of just one of the many advantages of finding derivatives. Have you noticed that I'm using word derivative now instead of slope of the tangent line at any given point? You know, those are totally equivalent, but isn't the word derivative just a lot easier to say? Okay, say hi and bye-bye.